Here's another question related to a confusion that may have come about by a statement, like this memory statement from Alexa. Is the ether real? I've heard it is not. However, now I'm confused if it could be. And so, I mean, it goes on, but basically, you might want to elaborate.
It's very real. It's the small excitations in empty space. So to elaborate on that and make it very concrete, to bring it home so you can internalize it, let me tell you what you're made out of. This is a picture of empty space. These are snapshots of empty space according to our deepest understanding of physics in what's called quantum chromodynamics, the theory of the strong force that Lawrence mentioned. What we perceive as empty space and what our eyes would see if they could see much smaller distances and resolve much faster times is actually a medium that's full of spontaneous activity. These are sometimes called virtual particles, sometimes called zero-point motion, sometimes called vacuum fluctuations, quantum fluctuations. Whatever you call them, they are fluctuations in the energy density of space on very short distance and time scales. And according to our theories, which have many other consequences we can check accurately and directly, this is what happens. The same kind of calculations that give this picture showing the distribution of energy in space when you take snapshots also allow us to calculate the mass of the proton and their properties very successfully. So in this picture, the brighter colors indicate a higher density of energy, and the lesser colors of lesser energy. And you can see that there's weather in space all the time. It's spontaneous, self-driven weather. Here's an animation of it, a movie, where you cut away some of the regions with not so much energy, so you can actually look inside, and you don't do such complicated. You do cruder calculations, so you can make a movie out of it. But this gives you an idea that inside all of us, all the time, there are these and everywhere in empty space too, there are these fluctuations that make the world kind of a gigantic lava lamp. Now what about that space? That's empty space. All this activity going on all the time, all these fluctuations. What are we? Well, here's what we are. If you take little excitations in those gluon fields that were shown, and also little excitations in quark fields, they can form a self-contained disturbance, like a hurricane in the storm, but a very wee disturbance that is pictured here. So you have to imagine in this picture, this is a disturbance in that medium that's fluctuating wildly all the time. You have to average out over all that stuff, and you get a tiny residual, which is this wispy thing, and that's the particle that we're made out of. Those are the kinds of things we're made out of. Little disturbances, analogous to disturbances of the crystal that make phonons. Here, there's no crystal, but it's empty space that can vibrate, and if you just make disturbances in the pattern of vibrations, those are seen as particles. Photons are one example. This is another example. So, in that very strong sense, we are ethereal beings. We're children of the ether, just as fish are children of the water, if you like. And citizens of Siliconia would be children of silicon. Really? Didn't you read that ether is totally discredited? That it was something that went out with the theory of relativity in 1905? Well, let's revisit the history. First of all, what was the ether? Or what is the ether? The original ether was something that was postulated by by James Clerk Maxwell, the great hero of 19th century physics, usually regarded together with Newton and Einstein as the triad, the holy trinity of theoretical physics, and my favorite, actually. He was trying to put together the laws of electricity and magnetism, as they were known at that time, into a consistent system. And he thought it would be useful to make a consistent set of equations to make a mechanical model that would be consistent, because it's a model and you know how mechanics work. So if you could find a model that has things that behave like electric fields and magnetic fields and make it fully consistent, it might have other surprising properties that would improve the equations. That was his strategy. And he succeeded. He made a model, very complicated, with magnetic fields described as vortices that spun around, and the electric fields were little greased balls that circulated around the vortices. This is a picture of it. And he got equations that way from this model that to this day we call Maxwell's equations, that are the successful equations of electricity and magnetism. You have to change things that weren't consistent with this picture. But then, having made the model, he threw it away because he said, okay, I've shown these equations are consistent. However I got there, you don't have to believe that. But there's some kind of substance, maybe not this particular arrangement of balls and vortices, but some kind of substance that supports the electric and magnetic fields, and he called it the ether. And Maxwell loved this idea. This is, to me, a really touching testimony. He was a very religious man, too, as you can see from this quote. He said, "The vast interplanetary and interstellar regions will no longer be regarded as waste places in the universe, which the Creator has not seen fit to fill with the symbols of the manifold order of his kingdom. We shall find them to be already full of this wonderful medium, so full that no human power can remove them from the smallest portion of space or produce the slightest flaw in its infinite continuity." So Maxwell loved his ether, and it's inspiring to think that space is not empty, that it's full. You know, nothing is wasted, and that, unfortunately, this same guy, 1905, in this relativity work, famously uttered the sentence that the introduction of a luminiferous ether will prove to be superfluous. So he worked from exactly the same equations as Maxwell. It's very ironic. He used in fact, it was Maxwell's study of Maxwell's equations that led him to special relativity. But whereas Maxwell loved the idea that there's a medium that supports it, Einstein really didn't like it at first, because the medium would have to have very strange properties, namely the properties that he wanted in special relativity. And he thought that was absurd. No material could have that property, so the heck with it. Well, he grew up, and by 1920, just before he got his Nobel Prize for the photon in 1921, this picture is his Nobel Prize picture, actually. He wrote, that more careful reflection teaches us, however, that the special theory of relativity does not compel us to deny ether. What it means is that if you have an ether, it has to obey the equations of special relativity, not Newtonian mechanics. But that's fine. Special relativity is good. There's not really a contradiction. So it took Einstein 15 years to wise up, but that's what it is. Indeed, Einstein's general relativity made space-time itself a dynamic material, an ether, if ever there was one. Space has many properties that you would think of as associated with the material in general relativity. It can weigh. This is the so-called cosmological term that, in fact, was measured, the density of vacuum was just measured to be non-zero a few years ago. It can warp, it can bend. This, according to general relativity, in fact, is how gravity works. Matter bends the space around it, and the space-time around it, I should say, and other particles do their best to move straight in that space-time, but the space-time is warped, so they wind up taking curvy paths, and that's how the force of gravity arises.